Hey guys, it's me again. Last video we talked about vectors. We introduced them. We said vectors describe movement. They have to have a magnitude and a direction. Magnitude being how far or how big or how fast. Anything quantifiable. Direction being to the left, to the right, up, down, forward, backward. But it has to have both of those. If it doesn't have both of those, then it's not a vector. We also talked about the fact that the direction can be shown in three different ways. The way that you'll see it in this class, you will see a direction angle that goes pretty much in the same way the unit circle goes. You'll see bearings, and those are counted a little differently than the unit circle. They start at a different place and go in a different direction. And then you have map bearings, which kind of ties both of them together. And then lastly, we did talk about the fact that even though vectors have magnitude and direction, what they don't have and what's not assigned to a vector is a specific location. So if you have the same movement from a different spot, it's still the same vector. If you go 5 feet west, I don't care whether you're starting at my classroom or you're starting in your bedroom. If you go 5 feet west, it's still the same vector. Okay. But today I want to put some things together. I want to go to the fourth thing on our agenda. I want to talk about adding and subtracting vectors and this thing that we get called a resultant. And so I'm going to flip over to a blank screen there, and I'm going to talk about this resultant thing. Let's say that you're at school and you start at my classroom, and I need you to go to the media center. So if this is my classroom door, let's go here. This is my classroom door. You head, of course, this way, and that is your first vector. That's vector number 1. And then you take a left because your direction changes, and you have to go to the left. So this is vector 2. And you end up at the media center. Okay? Now, you've taken a trip. You've put 2 vectors together. And by putting them together, of course, that's addition. Addition is adding things. What you get, and what's the result of your trip? Well, you left my room, you started here, and you went to the media center. This is what you did, right? So the result of your trip is you ended up at the media center from where you started my classroom. So the result of your trip is literally called a resultant. And that's all the resultant is. It's the result of the vectors that you put together from beginning to the end. It's where you started to where you finished. Now, why is that important? Because, or how will people make mistakes with that? Oftentimes, if I'm adding vectors, let's take this vector, and then I put this vector together, and then I can put a third vector here, and a fourth vector there, and I want the resultant. The big mistake people make is if this is the resultant, they just close the figure, and they have the resultant going that way. Well, that, of course, is incorrect, because in order for it to be the result of my trip, it would have to start where I started. Let's go black. It would start here and end there. So this is the resultant, because it's the direction that I went, that I ended up going in. Okay? So let me give you another example. Okay? So let's take this off. Let's scoot up a little bit. Let's say I'm going to take 3 vectors. Okay? I'm going to have vector A. What did I do there? Okay, I'm going to have vector A. Looks like that. I'm going to have in red, let's go vector B, which looks like this. And finally in gray, because I'm being colorific now, vector C goes straight down. I don't know if I like that, but that's okay. That's vector C. It looks like a pencil. That's neat. Okay, so I want to find out what would the resultant be if I took vector A and added it to vector C. Would that result be a vector that looks like this? I'm going to do 4 answers just because I can make it multiple choice, because I can do that. All right, and this might be what you see. Vector answer choice A would look like this. Answer choice B would look like that. Answer choice C would look like this. And answer choice D would look like that. Which one would be correct? Let's pause it and let's see. 1, 2, do, dee, do, dee, do, dee, do, dee, do, 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 dee, do, dee, do, 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 boom, boom. Let's work it out. Vector A, and it said the way we add vectors is we can either do the parallelogram method, or we can put them tip to tail. I like tip to tail because it describes the trip. So we went this direction, and then vector C we went to next. We went down, and how did we end up going? Well, we started where? We started here, and we ended there. So this is A plus C, which is, of course, answer choice A. If you picked answer choice A, you're doing wonderfully. That was marvelous. Okay, now, this is interesting. Let's take the same vectors. I'm going to erase these. And I'm going to put another example up. Actually, no, let's erase it, because you can rewind it if you want. So I'm going to erase that, like a space. This is fun. But I want to add something else. I want to do vector A plus vector B plus vector C. So I'm going to add all 3. Okay. Let's see, how does that work? Well, A, what would the answer be? What do you think? Well, let's draw it out, because this I think is really interesting, because this actually is a neat result. A would go this way. This would be A. And then you'd leave A and you'd go backwards for B. This is B. And then you leave B and you go down for C. So this would be C. So what would your resultant look like? Well, you started here and you ended at the same place. So the resultant, the result of your trip, is 0. You didn't move, right? You take 2 steps forward and then 2 steps back. We stay together because opposites attract. I'm sorry, that's a song. You take 2 steps forward, you take 2 steps back, you end up exactly at the same place. So when you're adding and subtracting vectors, you can actually end up where you started. That's actually neat. You can have a resultant of. Okay, so the other thing we need to talk about is actually subtracting vectors. We talked about adding. You get a result when you add. You put the You put together your trip, and it's from the beginning of the trip to the end of the trip. When you can also subtract vectors because you subtract things by adding their opposite. So you can have the opposite of a vector. The opposite of a vector, let's go with black. The opposite of a vector has the same magnitude, but it has the opposite direction. So negative A, the opposite of A, looks like that. The opposite of B looks like this, and the opposite of C goes up since C goes down. So if we're subtracting vectors, if we are doing vector B minus A, then we would go the direction of B. It would be B, same thing as B plus the opposite of A. And B looks like this. The opposite of A looks like that. So it would go this way, and then it would go that way, and our resultant would be that. So this would be the resultant of B minus A. So we subtract vectors by adding their opposite. So tip to tail, you just continue your trip, and your resultant is the beginning of your trip to the end of your trip. Big thing that you might want to realize is the resultant can be 0 because you may end your trip in the same place you started. Okay? That is adding and subtracting vectors, and I will see you next time.